On Discovery.com, I learned that most meteors burn up in the Earth's atmosphere. Ah! The atmosphere! Ah! But what happens to those that don't? Hello, Meteor. Trace here for D-News. Meteors and missiles can hit the ground with massive force. The 1908 Tunguska impact in Siberia flattened 2,000 square kilometers of Russian forest with an explosion 1,000 times greater than the bomb dropped on Hiroshima. The meteor left a crater, likely created local firestorms raised by superheated air, and particles from the impact may have cooled the entire Earth's climate. Tiny things hit planet Earth all the time, but they're usually not fast enough or large enough to worry anyone. Observations from satellites suggest anywhere from 100 to 300 metric tons of dust hit the Earth every day. Assuming 100 tons spread evenly across the whole surface of the Earth, we'd gain around 0.02 nanometers every year to the radius of our planet just from this cosmic dust. You can see some of these things as they fly through the atmosphere. Anything over 2 millimeters can create a streak of friction-spawned burnup. We call them shooting stars, but they're just dust and bits of rock. If a meteoroid is large enough to make it through our atmosphere and dent the solid surface of our planet, at least the size of a marble usually, then things get real. Most of us know what happens to the stuff on the surface, think again Tunguska event, destruction, dust clouds, etc. But new research from Duke University simulated high-speed impacts on sand and soil, so now we also know what happens under the surface of the Earth. They based this on missiles, but it also works for meteors. When an object hits the surface at high speed, the soil doesn't move out of the way, but it actually solidifies. Think of it like a crowd of people or a pack of snow. The faster you try to move through the mass, the more difficult it becomes. The research dropped a metal rod with a rounded end onto a pack of beads designed to simulate soil. They varied the strength of the beads to simulate speeds from 67 to 670 miles an hour, and found that as it sped up, more of the beads took the force of the impact more quickly, spreading that kinetic energy over a wide area of soil. As the projectile speed increased, the particles of soil couldn't get out of the way fast enough. When you think about it, this isn't actually a staggering discovery, but it's useful for the production of bunker-busting missiles. It was funded by the Defense Threat Reduction Agency after all, and it shows why when a meteor hits the ground, it doesn't burrow into our planet. All that kinetic energy dissipates through the soil at such a rapid rate and just creates, a blast crater. And in case you're wondering if all that energy could change the orbit of our planet, because that's what I was wondering, Earth is real big, y'all. We're orbiting at around 67,000 miles an hour, and we're pretty massive. If you were to blow a 100-mile thick chunk of North America off of the face of the Earth, we'd only alter the Earth's momentum by about 50 miles an hour. So these little meteorites, not going to do much. Meteoroid strikes like the Tunguska event do happen every 50 to 100 years or so we'll likely see another one in our lifetime. Keep that in mind. And now you know what's going on both above and below that impact crater. We got some really awesome questions last time we asked you all, so we're asking again, what do you want to know about science? What should we talk about in a future D-News? You can tell us down in the comments and keep coming back to testtube.com so you can get the answers to your questions, and thanks for watching.